Have you ever actually wondered what's inside the gadgets you use every single day? We're going to take a little journey, starting with just an idea, all the way to the electronic backbone that literally runs our modern world.
Okay, let's start with something super familiar, the computer mouse. It's simple, right? You've probably clicked one thousands, maybe millions of times without even thinking about it. It's just there.
But what if you popped it open? You wouldn't just find a little ball and some buttons. You'd find this whole complex little city inside. So the real question is, how does that intricate electronic world even get built?
So here's how we're going to break it down. We'll start with what I like to call the electronic skeleton. Then we'll go from the blueprint to the actual board. After that, we'll dive into how that amazing copper maze gets made, watch as the board gets its electronic brains, and finally, we'll talk about the massive, unseen revolution this all created. You see, before these nice, neat, green boards existed, electronics were just a chaotic mess, a bird's nest of wires connecting everything by hand. The solution was to invent some kind of skeleton to hold it all together in a super organized way. And that skeleton, my friends, is the printed circuit board, or PCB. It's an absolutely brilliant idea. It really has two jobs. First, it physically holds all the little electronic parts in place. But more importantly, it connects them all with a pre-designed network of tiny copper highways. And check this out. You can see it all happening right here. This is from a classic Sinclair computer from way back in 1983. Those shiny lines? Those are the copper traces, the highways. You can see the components soldered on. And you see those tiny little holes? Those are called vias. They're super important. They let the circuit jump between different layers of the board.
So how do we get from just an idea in an engineer's head to one of these physical boards? Well, it all starts with a plan, a blueprint.
Now, back in the day, this was a true art form. Designers would literally sit there and lay out these complex circuits on big transparent sheets using special tape for all the connections. It was painstaking work. Today, it's a whole different ballgame. It's all done with this powerful software called Electronic Design Automation, or EDA. It allows for mind-bogglingly complex and perfect designs. And this is just a perfect example of the old way. Look at this board from 1967. See those beautiful sweeping curves? That is the unmistakable signature of a human hand laying down tape, not some computer algorithm just finding the shortest path. It's like a little piece of art, really. Okay, so we've got our design. Now for the really cool part. How does that digital file become a physical thing you can hold? Well, the design gets sent to a factory, and this is where the manufacturing magic really begins. There are basically two ways they create that copper maze. The most common one is called the subtractive method. You start with a board that's completely covered in copper, and then you use chemicals to dissolve or etch away everything you don't want. It really is like a sculptor carving a statue out of a block of marble. The other way, the additive method, is the exact opposite. You start with a bare board, and you add the copper only where you need it, kind of like 3D printing. And don't picture some guy on a workbench doing this. We are talking about massive, automated, industrial factories. You've got these huge panels with dozens of boards on them, getting dipped in chemical baths and run through all sorts of complex machines to create these circuits with incredible precision. Modern gadgets are so complicated, there's no way to fit all the wiring on just one surface. So what did? They started stacking them. This image is a cross-section of a multi-layer board. Remember those vias we talked about? See that copper-colored band going straight down? That's one of them. It's a tiny, copper-plated tunnel that connects the different layers, turning the circuit from a flat map into a 3D skyscraper. So at this point, we've got this beautiful but, honestly, pretty useless piece of fiberglass and copper. To make it actually do something, we need to populate it. We need to add all the electronic components, give it its brains. So how do you attach all those little bits and pieces? Well, for a long time, everything was through-hole. You'd literally stick the components' little wire legs through holes in the board and solder them on the other side. But the real game changer, the tech that made our modern world possible, is called surface mount technology, or SMT. That's where tiny components are placed right on top of pads on the board surface. And just look at the difference. It is staggering. On the left, you've got a board from the 80s with its big, chunky through-hole parts. Then on the right, a modern board. Those SMT components are just a fraction of the size. That means you can pack way more power and intelligence into a much smaller space. This is why your phone is a supercomputer and not the size of a briefcase.
You know, it's easy to get lost in all the technical details. But let's just zoom out for a second. The invention of the PCB wasn't just some small improvement. It was a full-on, world-changing revolution.
And just to give you a sense of the scale we're talking about, back in 2014, the market for just the bare, unpopulated boards was worth over $60 billion. That's just the empty skeleton, the foundation of this absolutely colossal industry.
So why does all this matter so much? Well, because PCBs made it possible to mass-produce electronics automatically. Instead of a person painstakingly wiring everything by hand, a machine could print the circuit. Costs plummeted, reliability went through the roof. It's what unlocked miniaturization, and it is, without a doubt, the foundation of every single digital device that shapes our lives.
So the next time you pick up your phone, just take a second to remember that unseen skeleton inside, that multi-layered marvel of engineering. The device in your pocket has dozens of these complex circuits inside, each one the product of this incredible process. And it really just leaves you with one question, right? What kind of future are they going to build for us next?